So in the last session we've been talking about constructible numbers. A real number alpha is constructible if it belongs to a finite extension of Q for some alpha n's in R such that the degree of Qj plus 1 Qj is equal to 2, or the Q of alpha 1 dash dash alpha n over Q is equal to 2 to the power of n for some n. So that is the only way we can construct that real numbers geometrically using a straight edge and a compass. So let us derive some conditions for an angle to be constructed. Suppose you want to construct an angle. So can we construct any angle? That is a question. So what we do is, let us assume that this can be constructed. So let us take a unit length here and draw a perpendicular line. So this is 1. So cos theta is equal to this element by 1, or its alpha. So if alpha is constructible, then theta is constructible. Because cos theta is equal to alpha. See, if alpha is, see, how do you draw if alpha is constructible? What we do is draw a line. So alpha is constructible. Then draw a perpendicular line here. Then use the compass with 1 unit and strike here. So this angle will be. That is how you draw when alpha is known. And if theta is constructible, then alpha is constructible. So the result is an angle theta is constructible if and only if cos theta is constructible. So let us do some problems using these results. the first problem which you are going to do is it possible to double the volume of a cube, of a known cube, meaning you know everything about a cube and you want to construct a cube that has got the double volume of the given cube. So let us assume that the cube is of side 1, for example. You can take any side, any length, but I'm going to take 1. So 1, 1 and 1. So the volume of the given cube is equal to 2. So the volume of the new cube is equal to, so the volume of the given cube is 1. So the volume of the new cube is 2. So each side of the new cube has to be cube root of 2. So our question is reduced to whether will you be able to construct cube root of 2. But cube root of 2 belongs to Q of cube root of 2. And the degree of the simple extension cube root of 2 over Q is equal to 3, which cannot be represented as 2 to the power of r for any integer r. So that means cube root of 2 cannot be constructed. That means a cube of volume equal to 2 cannot be, volume equal to 2 cannot be The next problem we are going to consider is can we draw a square whose area is same as a known circle. Or as a constructible circle or known circle, that is fine. Known circle means you know the radius of the circle, meaning you can construct the radius of circle. Question is, see, so the area is, this is the area, right? So we want to construct a square whose area is this. Area should be same. So if the side is a square, it should be pi r square. So what is A? A is equal to R root pi. R can be constructed, definitely. But root pi is not. Root pi cannot be constructed because q of root pi column q cannot be equal to 2 to the power of r for any r belong to C. So that means a square of same area as a circle cannot be constructed. Before we come to the next problem, I want to mention one result in the factorization of polynomials. We are not going to prove this one here, but we are going to make use of this result. The result is if f of x belongs to z of x, z of x means coefficients of this polynomial are from integers, can be factorized into polynomials of lower degrees, can be factorized into polynomials of lower degrees if and only if it can be factorized into polynomials in Q of x of same degree. We are going to make use of this result in our next problem. So our problem is it possible to trisect any angle? Well, there are some angles which can be easily trisected. For example, if angle is equal to 180 degrees, each of the trisected angle will be 60 degrees, and cos 60 is equal to half, which can be constructed. So there are angles which can be trisected. My question is it possible to trisect any angle? So we are going to show a particular angle that cannot be trisected, and the angle is theta equal to 60 degrees. Okay, so let's take, okay, and you can see, so cos 60 equal to cos 3 times 20. That is actually equal to cos 3 theta equal to 4 cos cube theta minus 3 cos theta. You can derive this one using the elementary trigonometry. So I'm not going to prove this one. So this will be 4 cos cube 20 minus 3 cos 20. So let us take alpha is equal to cos 20. So this is what is this? This is half. Half equal to 4 alpha cube minus 3 alpha square. Sorry, 3 alpha. Sorry. So this implies 8 alpha cube minus 6 alpha minus 1 is equal to 0. So we have a polynomial in Z6. If this can be factorized, one of the factor will be a linear factor, meaning a factor with the degree 1. One of them will be 1 and another, the next will be either 2 or 1, 1. So definitely one of the factors, so one of these factor, if this polynomial is reducible, meaning can be factorized into polynomials of lower degree, then one of these factors is linear. Linear polynomial in Z of x. So definitely that has to be either 8x plus or minus 1 or 4x plus or minus 1 or 2x plus or minus 1 because of this. So none of these, you are going to verify that. I am not going to do it. What you can do is you can divide this one by each of this and see whether you can find that as a factor. None of these are factors of 8x cube minus 6x minus 1. And that implies 8 alpha cube minus 6 alpha square, or 8x cube x square x minus 1 is irreducible. So what does that mean? That means, see, you have this polynomial in Q of x and which is irreducible in Q of x, in Q. So if alpha is a 0 of 8x cube minus 6x minus 1, then Q of alpha, the degree of Q of alpha over Q is equal to 3. Because this is a irreducible polynomial for which alpha is 0 and its degree is 3. So this is going to be 3. This implies alpha is not constructible. That implies 20 degrees is not constructible. That means 60 degrees cannot be trisected, or 60 degrees cannot be trisected. Our next question is, can the angle 36 degrees be constructed? The way we are going to look at this problem is like this. Let's draw a line and mark a unit on this line. Then let us assume that we can draw a 36 degree angle. We are not yet sure, but we are assuming that it can be drawn. And mark a point 1 unit away from here. And join these two. If you know this side, the length of this side, this is actually 1, this is 1, and let us take this as r. If you know this r is constructible, then we know that 36 degree can be constructed. So the problem of whether the angle can be 36 degrees can be constructed is translated into the problem whether this r can be constructed or not. So this is an isosceles triangle, 1, 1. So this is actually 72 and this is 72. What we do is we bisect this angle. So this is actually 36, 36. So this is 36. So this is 72. So this is r. So this is r because it's an isosceles triangle. And this also is an isosceles triangle. So if this is r, this is r. So this will be 1 minus r. So let us make this as r. So here the triangle OPQ is similar to this triangle. O is 36, so this will be QPR. I'll write it as triangle QPR. Triangle QPR. So we can write as OP by QP is equal to PQ by PR is equal to OQ by QR. What is OP? OP is 1. QP is R. Is equal to, we'll take this PQ R by 1 minus R. We don't want to take this. This is enough. We got an equation in R. So this implies 1 minus r squared equal to 1 minus r. And that implies r squared plus r minus 1 is equal to 0. That implies r is equal to minus 1 plus or minus root 5 by 2. And this actually belongs to Q of root 5. And the degree of q root 5 over q is equal to 2. That implies R is constructible. And that implies 36 degrees is constructible. We'll do a couple more problems before we close this session. The next problem is it possible to trisect 72 degrees? We know that there are angles which cannot be trisected. But that doesn't mean that all the angles cannot be trisected. So if you trisect this one, what will be each one? So if 72 degrees can be trisected, each angle will be of 24 degrees. So if you can construct an angle of 24 degrees, we are done. Cos 60 is equal to half. That implies 60 can be constructed. And we know that 36 degrees can be constructed. And that implies 60 minus 36 degree can be constructed. Because if you know how to draw alpha, if you know how to draw alpha, or if alpha can be constructed, and if beta also can be constructed, then we can subtract from here like this, beta, and this will be alpha minus beta, and this implies 24 degrees can be constructed. That means 72 degrees can be trisected. The next problem is it possible to draw a regular 9 gun, means a polygon of 9 sides, regular means it's equal. So all the sides are equal, all the external angles are equal, or internal angles are equal. So for any polygon, the sum of external angles is equal to 360. So for a regular 9 gun, each external angle is equal to 360 by 9, that is 40. So if 40 can be constructed, then we are done. But cos, but we know that 60 degrees cannot be trisected. That implies 20 degrees cannot be constructed. If 20 degrees can be constructed, 40 degrees can be constructed. So 20 degrees cannot be constructed means 40 degrees cannot be constructed. Implies regular 9 gun cannot be constructed. So we are going to do our last problem on geometric constructions. The last problem is it possible to construct regular 15 gun? So it's a regular 15 guns means a polygon with all sides equal. There are 15 sides, all angles are equal, all internal and external angles are equal. So each external angle will be 36 degrees by 15, that is 24 degrees. But we know that 72 degrees can be trisected. So that means 24 degrees can be constructed. And that means it is possible to construct a regular 15 gun. So that is going to be our end of our session on geometric constructions.